Hello, this is Mrs. Butcher, and this video is about graphing logarithmic functions. Now, graphing logarithmic functions is a lot like graphing the exponentials because exponential functions and logarithmic functions are inverses of each other. And it's hard to just make a table given just a straight up logarithmic function. So here is how you would graph a logarithmic function without using a calculator. Alright, we're going to graph f of x equals log base 2 of x. And the first thing that we're going to do is find the inverse. Now remember, to find the inverse, you switch x and y, and then you solve for y. So our inverse is y equals 2 to the x power. So let's make a table of values for y equals 2 to the x power. First of all, we know that this is going to have a horizontal asymptote at y equals 0. And then we can plug in anything we want to for x. So if we plugged in -1 for x, 2 to the -1 power is 1/2. If we plugged a 0 in for x, 2 to the 0 power is 1. If we plugged a 1 in for x, 2 to the 1 power is 2. We could square it. 2 squared is 4. So we have these points, and we know what that looks like when we graph it. Only now we're graphing the logarithm. So the next thing you do after you find the inverse and make a table is you have to switch your table. So if this is the table for this, here we're going to make a table for this. And all you have to do, because they're inverses of each other, is switch x and y. So instead of -1, 1/2, I have 1/2 -1. Instead of 0, 1, I have 1, 0. 1, 2 becomes 2, 1. And 2, 4 becomes 4, 2. So this is the table for log base 2 of x. And then we can plot that on the graph, which I'll do on the next slide. And also, if your horizontal asymptote for the inverse is y equals 0, you're going to have a vertical asymptote, because the inverse of horizontal is vertical, at x equals 0 for your logarithm. Okay, so I just copied over the information from the last slide with the table and the asymptote. So we're going to put those on the graph. With the vertical asymptote at x equals 0, you're going to put your dashed line right here. Just like with the exponentials, you are required to put in your asymptote. Just remember, now it's a vertical line with a logarithm. And then we can plot the points. So we've got 1/2 and -1 would be right there. And 1, 0 would be right there. 2, 1 is there. And 4, 2 is here. And so we have this curve that approaches the asymptote. It looks exactly like the exponentials did, but turned sideways. So there's the graph. Remember, if you're going to extend it all the way out, you need to put it in the right place. Otherwise, just leave it 3 minimum points. All right, so that's it. That's the graph of log base 2 of x. Now, of course, I'm going to ask you for the domain and range. So our domain for this, our x's are now limited to starting at 0, and then go on out to the right to infinity. Our range goes bottom forever, down forever, and up forever. So our range is -infinity to infinity. It's exactly the opposite of what it was when we had an exponential function. Okay, for this example, we're going to graph f of x equals log base 2 of x minus 3. So we just did the graph of log base 2 of x, and if you remember your transformation rules, when we have a -3 that's with the x, that's going to shift it all to the right 3 units. So this graph that we're about to do should look exactly like the one we just did, only scooted to the right 3 units. And that means that your vertical asymptote is going to get shifted over to the right 3 units. So when you're looking at these, and if you want to automatically know where your vertical asymptote is going to go, you just look at this number right here. And of course, it's going to be the opposite. It's going to be at x equals +3. So I'm going to write that down. Vertical asymptote, x equals 3. So remember, the first thing we're going to do is find the inverse. We're going to switch x and y. So we'll say x equals log base 2 of y minus 3. Make sure you put that in parentheses. And then the inverse of it would be 2 to the x power equals y minus 3. And then we're going to add 3 to both sides. So we have y equals 2 to the x power plus 3. See how plus 3 would make your vertical asymptote be at y equals 3? I mean your horizontal asymptote, sorry, be at y equals 3. And it's the opposite of our vertical asymptote, x equals 3. So we'll make a table for these values. If x was negative 1, we'd have 1/2 plus 3 is 3.5. If x was 0, we'd have 2 to the 0 power is 1 plus 3 is 4. If x is 1, 2 to the 1 power is 2 plus 3 is 5. And if x is 2, 2 squared is 4 plus 3 is 7. So then for our logarithm, we switch x and y back. So basically you're switching x and y to find the inverse, and then you're switching them back to go back to the logarithm. So we've got 3.5, negative 1, 4, 0, 5, 1, and 7, 2. We're going to plot these points with this vertical asymptote, and we'll see what that graph looks like. Okay, so we will sketch in our vertical asymptote through x equals 3, right here. And then we have a point at 3.5, negative 1, so there. 4, 0, there. 5, 1, there. And 7, 2, here. And as you can see, it looks exactly like the one we just did, only scooted to the right 3 units. Domain on this, the lowest x value we have, the leftmost x value we have is 3, and it doesn't touch it, going to infinity. And then the lowest y value, the range, negative infinity, moving on up to positive infinity. Okay, and now for this last example, we're going to graph using our calculator, because I will let you use the calculator for these. You just have to understand how it all works and how it looks. And now that we've gone through a couple without, I think you will. So we're going to graph y equals the natural log of x plus 1. So you have a natural log button on your calculator. Just make sure you remember these parentheses right here when you're entering it in. And it should look like this. Now notice that it looks like it stops right there. That's just an issue with the calculators. If we find the inverse of this, we know that it's base of e to the x power equals y plus 1. So it would be y equals e to the x and then minus 1. That means that we would have had a horizontal asymptote at y equals negative 1. Or you can look at it as this plus 1 gives us a horizontal shift to the left 1 unit. So your asymptote, which is normally at 0, is now at x equals negative 1, and that must be drawn in there. So we have a vertical asymptote at x equals negative 1. And then you know that an asymptote is a imaginary line that your graph approaches but never touches. And when you draw that, I want you drawing it approaching it with an arrow on the end, showing that it continues and keeps going down forever. The rest of the points you can get from the table. And then when you sketch in the graph, you just follow the points and put an arrow on the end to indicate that it keeps going that way as well. So the domain on this graph is going to be negative 1 to infinity, and the range will be negative infinity to positive infinity. All right, so that's it for this lesson. You guys have a good night, and I will see you tomorrow.